Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Amira binti Muhammad Sardi, and today my team will be presenting to you about stormwater management and road tunnel, or also known as smart tunnel. Allow me to introduce you to our team members. Our team members consist of 4 people, which is Tengku Arsyad Danish Darwish bin Tengku Jusuf, me Nur Amira binti Muhammad Sardi, Nobaiti Husna binti Muhammad, and lastly Wan Hana Kalila binti Muhammad Usni. So, what is SMART? SMART, which stands for Stormwater Management and Road Tunnel, is a project in Kuala Lumpur designed to address flooding issues in the city centre. The initiative is a collaboration between MMC Corporation Berhad, Gamuda Berhad, and government agencies like the Department of Irrigation and Drainage Malaysia and the Malaysian Highway Authority. The project aims to divert floodwaters away from critical areas along Sungai Kelang, reducing the risk of flooding in the city. One of the key features of SMART is the integration of a motorway tunnel to help alleviate traffic congestion at the southern gateway to Kuala Lumpur. This tunnel will provide an alternative route for motorists entering and exiting the city centre from highways like the KL to Seremban Highway and Federal Highway. By reducing traffic congestion at the southern gateway, SMART aims to improve travel times and overall traffic flow in the area.
Hi, my name is Narvatius Navinti Muhammad, matrix number A196667, and I will be explaining about the purpose and design of this tunnel. The 9.7 kilometer long Smart Tunnel is the longest stormwater drainage tunnel in Southeast Asia and the second longest in Asia. And it is also the first in the world to feature both a flood mitigation system and a motorway channel. So, the main purpose of Smart Tunnel is to divert large volumes of water during flash floods from entering this critical stretch of an area that we've shown in the previous slide via a holding pond, a bypass tunnel, and also a storage reservoir. A sophisticated and modern flood detection system, or FDS, provides real-time flood forecasting information. This enables efficient and also safe management at the operation of the tunnel. As we can see in this diagram, the tunnel has 4 modes of operation to adapt to different water levels. In the case of no storm, traffic is allowed on both the upper and lower decks, depending on the level of storm and flooding that occurs in the area. Mode 2, 3, or 4 would be activated, which will be further explained by my groupmate later. Since this tunnel was opened to the public in May of 2007, it has managed to divert floodwaters 40 times and averted around 1.4 billion ringgit in public damage. However, at the design stage of SMART, a dual-purpose concept was born from the ingenuity of the project advocate, and the motorway tunnel was integrated into the system to relieve traffic congestion. In other words, it was also built with the purpose to introduce an alternative route surrounding the heavily packed area of the financial, business, and also commercial hub of Kuala Lumpur, Malaysia. For the further safety of motorists, the motorway traffic is also designed to be unidirectional, and safety features such as ventilation shafts, cross passages, CCTVs, fire extinguishers, and air ventilators have been incorporated into the design in compliance with international and Malaysian standards. Variable message sign, or VMS, of amber-colored LEDs provides a means of informing the motorist of any traffic advice or message, which will help the motorist to avoid any inconveniences or incidents, and in general, just to facilitate the flow of traffic. All these features are under constant supervision by the Motorway Control Center. This project has been a great challenge for the local engineers involved in the construction and management of the SMART project, as not only it runs below congested roads, it is also near sensitive structures and has to take into account a lot of geological ground conditions.
Assalamualaikum and a very good day. My name is Tengku Arsyad. My matrix number is A194597. So I'm going to present on how a stormwater management and road tunnel or smart tunnel work. First, the tunnel itself consists of several sections. From the diagram, you can see that the upper 2 sections are roadway that allow traffic to flow in one direction for each roadway. The third section is the stormwater tunnel that is located at the bottom of the tunnel. Smart tunnel can be operated in 4 different modes according to the situation. This innovative infrastructure serves a dual purpose, alleviating flood issue and facilitating road traffic in Kuala Lumpur. Let's start with Mode 1. Under fair weather conditions with little or no rain, the smart tunnel operates solely as a traffic tunnel. Vehicles can pass through the tunnel without any interruptions, ensuring smooth traffic flow. Mode 2 is activated when moderate rain occurs and the flow rate recorded at the confluence of the Upper Sungai Klang and Sungai Ampang, referred to as the L4 flow station, is between 70 and 150 cubic meters per second. In this scenario, excess floodwater is diverted to the smart holding pond. The lower drain of the tunnel is used to convey flood flow to the Desa attenuation pond while 50 cubic meters per second is discharged to the city centre. Importantly, the road traffic tunnel remains open to road users during this mode. Mode 3 comes into play during a major storm event when the flood model forecasts a flow rate of 150 cubic meters per second or more at the L4 station. In this case, only 10 cubic meters per second is discharged to the city centre. During Mode 3, traffic is evacuated from the road tunnel. All incoming traffic will be diverted away from the tunnel by the closure of the tunnel's entry points. Each passage and emergency exits are checked thoroughly before the watertight doors are sealed shut. If the heavy rainstorm stops early or due to specific circumstances, the traffic tunnel will not be flooded. The road tunnel is typically reopened to traffic within 2 to 8 hours after closure. Finally, Mode 4 is activated if the heavy rainstorm prolongs, usually confirmed 1 to 2 hours after Mode 3 is declared. The road tunnel is then used for the passage of flood flow once the traffic evacuation is complete. The road gates at the end of the motorway will be closed before opening the hydraulic powered water gate to enable stormwater in the tunnel and successfully divert it from the city. In this mode, the road tunnel will be reopened to traffic within 4 days of the closure, ensuring that both flood management and traffic flow are effectively managed. In conclusion, the smart tunnel is a remarkable example of multifunctional infrastructure, seamlessly integrating stormwater management and road traffic functions. Its different operational modes ensure that Kuala Lumpur remains resilient against flooding while maintaining road connectivity. Thank you for
Hai,
your attention.
Assalamualaikum. My name is Wan Hana Kaila binti Wan Mama Usni. Nama matric A194366. I will explain about advantage and disadvantages. This project offers significant advantages in terms of flood mitigation and traffic management through critical issues facing rapidly developing urban areas in Malaysia. By serving as both a stormwater drainage system and a traffic tunnel, Smart Tunnel efficiently utilize limited urban space and resources. The primary benefit is the reduction of flooding in vulnerable areas of the city, potentially saving millions in flood damage costs and improving the quality of life for residents. These tunnels also help alleviate traffic congestion by providing alternative routes for vehicles, thereby improving urban mobility and potentially boosting economic productivity. One of the most innovative aspects of smart tunnels is their dual-purpose nature. By combining stormwater management with traffic infrastructure, this project makes efficient use of limited urban space and resources. The economic benefits of smart tunnels are substantial. By reducing flood damage, this project can save millions in repair and recovery costs. Improve traffic flow can boost economic productivity by reducing time wasted in congestion. Lastly, the implementation of such projects also showcase Malaysian engineering capabilities and commitments to innovative urban planning solutions, potentially attracting international attention and investment. However, these benefits come with notable drawbacks. This is disadvantages of smart tunnels. The construction and maintenance of smart tunnels involves substantial costs due to their complex engineering requirements. There are also environmental concerns as the construction process may impact local ecosystem and groundwater system. Safety risks are another consideration, particularly the potential for flooding within the tunnel during extreme weather events, which requires sophisticated monitoring and management system. Furthermore, while smart tunnels can help reduce traffic congestion, they may not fully solve the issue in rapidly growing urban areas with increasing vehicle ownership. The tunnels also rely on complex technological systems for operation, which could be vulnerable to failures or cyber attacks. Despite this challenge, smart tunnel projects represent a forward-thinking approach to urban infrastructure that, if carefully planned and executed, can provide significant benefit to Malaysia's city grappling with the dual pressure of urbanization and climate change.
In conclusion, the SMART project in Kuala Lumpur combines flood mitigation with transportation infrastructure to address flooding and traffic congestion, demonstrating Malaysia's commitment to sustainable urban development. The design of the tunnel allows it to manage stormwater and act as a motorway, maximizing urban space use and reducing flood risk. Despite challenges, the project offers benefits like improved traffic flow and economic opportunities, showcasing Malaysia's engineering capabilities and providing insights for creating resilient urban environments worldwide. And that is all from us. Thank you.